On tonight's video, I just want you to experiment with some polar equations and their graphs. First of all, don't use a calculator. These are all equations of circles in polar form. I would like you to use the method we did today with the complete the square. Change these from polar form into rectangular form to find the radius and the center of the circle given by the polar equations. So I gave you 4 examples, so you do 4 complete the squares. And then I want you to generalize what is the generalization that you can make from these examples. So if you want to shut off the video now and work on these will take you a few minutes to do. The next thing is I want you to take your graphing calculator, and I'm giving you equations in polar form that are called rose curves. And here are some rose curves. You can, if you want to freeze the video right now and just take your graphing calculator out and one at a time, don't put this in like R1, R2, R3, R4. I want you to look at these individually: 2 sine of 3 theta, 2 sine of 4 theta, 2 sine of 5 theta, and 2 sine of 6 theta. Then when you get done looking at those, they should be really quick to see on the graphing calculator. I want you to change each one of these sines to a cosine and see what the difference is. And then I would like you to make some kind of a generalization or figure out what is the relationship between the coefficient of theta, 3, 4, 5, and 6, or whatever number you want to put in there, and the number of petals on these roses. If you zoom in, after you've graphed it, you'd be able to see these rose curves a little better because they turn out to be very tiny if you have just a standard window. So I'll give you a few minutes. You should shut off the video and use your graphing calculator to figure that out. And then the last thing, I want you to zoom out again. And now I'm giving you some spiral equations. And actually, there's only one spiral equation. Instead of using sine or cosine in front of theta, I just want you to put r equals theta. And when you press your window button, you should have theta max being equal to 2 pi. That's standard. So graph that, and then change your theta max to 3 pi. And then change your theta max to 4 pi. See what the difference in all of these graphs are. Theta max equals 6 pi. And theta max equals 8 pi, and then finally theta max equals 14 pi. So you'll get all these different spirals, which are pretty cool. And I'm wondering if you can explain why do these graph out to be spirals? And then I want to see if you know what is the relationship between the theta max that you've changed in your window and the number of spirals that occur in all of these graphs. And that's it for the video. I think you're going to have some work to do these problems, and I'm going to also try to attach this as a Word document in Schoology if you'd like to print it out. See you tomorrow.